Today on the Skid Factory, we're building a 1500 horsepower, 10,000 RPM D-stroked Barra. Woody and I have taken a trip down to the Gold Coast, which is a couple of hours from where we live, to hang out with our mate here. This is Robby.
Guys.
Hey, you may remember Robby from such adventures as blown up Fox Body Mustang on the side of the freeway in the middle of a hurricane.
That was an adventure.
Robby was our saviour during Drag Week in 2019. He was the man that basically cobbled together a operating Barra out of two broken ones. So, and today we're going to start from scratch with one, and this is Robby's in charge of this build, so he's going to give it his all.
Well, Robby started from scratch. It's a bit further along now.
Yeah, but I should point out that the combination is not mine. All the thought has been, I think Christian at Golby's and his crew has put a fair bit of input into this. Most of the parts have come from Christian. It's a 3.8 Nitto, Nitto rods, Nitto pistons, Nitto crank. Some of the nicest stuff I've ever assembled as far as the build quality. So where do we start with this?
Well, bit of backstory, I suppose. You're probably wondering what is this engine for. You may remember a ridiculous engine swap that we did, putting a Barra into a Bedford van. So if that wasn't silly enough, I think it ended up making about 730 horsepower.
You visited Haltech and made,
You made 680 at Haltech, and then I think the Hoff had they put a bigger 5-bar map sensor in it, and then put more boost in it, and it ended up about 730, which is pretty much winging out the turbo they had on it. So that was obviously not good enough for Millsi, because
roll racing and stuff.
Because Millsi's mental.
We did a bit of stuff in it, no?
It goes all right, roll racing, doesn't it?
Yeah, I think I don't know if it was a track day or roll racing or something like that anyway. He races around a bit. There's some videos somewhere. But since then he's obviously got even more mentally ill and decided that he needed not 1,000 horsepower Bedford van, a 1,000 kilowatt Bedford van, which is, I don't know, 1,500 horsepower or something.
Close enough.
1,400 horsepower.
Yeah.
So that's the sort of brief behind this build, is that he wants to have the fastest Bedford van in the world, which I wouldn't have thought would have been too difficult because he probably already was that. But Millsi doing Millsi things, he's gone, I'm going to build a 1,500 horsepower engine, but I also want it to be a 10,000 RPM capable rever. So that's what the de-stroking is for. So this build is obviously not a $200 green top that you put in your 600,000 K old taxi. It is a high-end sort of build. This stuff is expensive, I guess.
Yeah.
Get what you pay for, again. So you can see it's got steel main caps. That's just a strength thing. Originally they're cast, and cast iron will yield at some point. So security thing, it's pretty common for, if you had a 2JZ or something like that with making this sort of power, you would replace those caps as well. It's got studs. It also has a girdle which goes over the top of it. All that's just to stop everything walking around. We've taken this front cap off, and Robby's going to explain to you what this is.
Okay, well, a lot of engines nowadays with the big power and trans brakes, and it's a transmission related thing, but it's loading the crank up and wearing the thrust out. Now these are a number 5 thrust bearing, okay, and it's just a normal Abbott bearing, and it relies on splash to lubricate it, and they do wear out, and the crank ends up getting pushed all the way forward in the engine. So we machine the front cap and the block and have a nice square face there for it to rest against, and we machine the crank up to put a rollerised thrust in there. It's got needle rollers in there, it can cop a lot of load, and it saves the thrust. We've never had a problem with one yet. We've done quite a few of them for all different engines, small blocks, LS, Barras,
It's
RVs.
like a security thing. Like
Definitely.
if that's in there, it's not going to happen.
Yep.
Some people might just try and get away with on a cheaper build just having those
That
and
yeah.
managing your converter pressures, but it's up to
True.
anything could happen depending on who built the gearbox, how they've set it up.
Absolutely, and there's all different ways to skin a cat, and you're right, I do know guys that don't run a roller thrust and they think it's a waste of time, but the guys who chop out their thrust,
Yeah,
it's money well spent.
yeah, that's it.
Yeah,
So your
it-
crank's virtually ruined once you've chopped out that thrust bearing and everything's moved forward. It's
Oh, look, I've seen them go far enough that the counterweight starts chopping into the block.
jeez.
Like, so they've gone forward 3-4 mil,
Yeah.
sometimes more, you can move the crank in the block back and forward.
So crankshaft's probably the big deal here.
It's a beautiful piece. When I measured it, I couldn't measure a tenth of a thou difference in the journals themselves.
And that's as received, so as built.
Mate,
Yeah.
all I've done is balance it and put a thrust on it.
Yeah, sweet.
It is a very, very nice bit of kit. Not cheap, but you definitely
Race
getting a bit
engines
more for
aren't
your buck.
cheap. Bedford vans aren't cheap.
That's right. Yeah.
So it's worthwhile saying, like, you can literally just get on Golby's website and just buy all this stuff, like
Right.
straight up. It's
Mate.
none of this has been specially made or anything like that. It's all just tick the boxes, check out the cart, wait for your package to turn up. So
100%.
it is great quality stuff, but it's not unobtainium sort of race car stuff, is it? It's
No. Okay, so I've had it together and knocked one piston rod out for you to have a look at it. It's all Nitto. The pistons are made by CP for Nitto. It's a nice heavy skirt construction, nice and thick crown. It's a 220 wall pin. Got to have a
like
heavy
220 thou. What's
In
that
mil.
in millimetres?
Don't put him on the spot.
Quick math.
pin. What's it, about 5, isn't it?
Yeah, I don't know.
Oh, it's
Big
more
enough.
than that. It's 6 mil.
It's pretty thick.
6 mil. Yeah, so they're 1.2 ring and 3.5 mil oil ring. I've set the gaps at 28 and 30. We've got plans of a fair bit of pressure in there, so I'd rather have a little bit more gap. The rod construction, it's a beautifully made piece. Nice radiuses everywhere. There's no sharp edges. I'll be pretty sure it's nice material, but the tolerances is just beautiful.
This particular block actually came from Atomic in Melbourne. Millsi bought maybe 4
It was 4, yeah.
$200 Barras,
Yep.
and every time they got sent away to be sonic tested, they were not up to the task. So every time that job was done, that cost money. So eventually ended up just going with a pre-prepared block that's already been tested, and
get this sorted
it's
out.
been grout filled as well. So it's about 3/4 grout filled for strength. That's a nice ring compressor.
What we use.
We need one of those.
The standard Ford crankshaft is a well-designed piece which has been pushed to over 1500 horsepower in the past. A factory Barra is under square where the stroke is longer than the bore diameter. The crank and rod combination Millsi is using de-strokes the crankshaft by 3.5mm, making the engine a 3.8 litre. The conrod length is also increased by 3.5mm and in return provides a better rod ratio, allowing the engine to rev harder with less strain on the conrod. $12mm atomic main studs and girdle are being used along with the factory Ford windage tray. Each bolt is marked with a paint pen, validating that it's been correctly installed. It also helps Robby sleep at night. Billets, oil pump gears and backing plate are a common upgrade for the factory Ford oil pump. Adding a radius to the galleries helps promote flow within the pump.
Okay, so we with a lot of our boosted stuff, we're using a perimeter ring copper gasket style setup. The ring itself is made out of AB bronze. Millsi bought a setup ready to go. It's not quite how I would do it. We used to do a ring and groove the block. We still do that from time to time. The only reason I'm not using these is because I like to have between 5 and 6 thou protrusion of the ring above the gasket, so it's got a bit more clamping force on the perimeter ring itself. I don't normally make them that big, but it's not a problem, it's just a bit more area to clamp on. I've just used these existing gasket to get away with that, but this ring here had only 2 thou protrusion on the face between the block and the head, which in my opinion isn't quite enough. This one's got 5, and we just use a gasket to locate them nowadays. We found, I mean, if it's shifting, you've got bigger problems than not having a groove. And as far as having a groove on the bottom and sealant properties, well, it doesn't leak when it's a flat face to the aluminium head. I can't see how it's going to leak with a flat face to an iron block. We've had pretty good success doing it that way. Made pretty big horsepower without issues, so that's how we do it now. Plus, it doesn't compromise the block at all. If someone wants to change it in the future or get another set of rings, they don't have to be specially made with the groove. You've got to have someone who's really onto it to make it with the groove, otherwise they twist when they part them off. And we like to have like nice flat faces in between the two and nice consistent flat faces, and it's a whole lot easier to do it like that.
So the purpose of this copper gasket is really just to locate those rings. Those rings are sealing your combustion pressure.
Yep.
This is just locating them and also sealing your
Correct.
Coolant and oil passages.
Yep. Its purpose is to locate the perimeter ring for one. Yep. But its main purpose is to seal the oil in and seal the water in. It's just a gasket for that. It's got no combustion sealing properties whatsoever.
Yep. Cool.
Robby has marked the block where the gasket sits so that the sealant can be applied in the correct places. As mentioned, this only seals the water and oil passages. The copper gasket is basically a spacer and locator for the bronze fire ring. Moly grease is applied to each head stud. This is to ensure the correct torque is reached when tightening the nut. A Barra in a Bedford van is pretty unique. That's why Kelford Cams etched a custom Skid Factory logo and a picture of the van onto Millsi's camshafts. These are a 296-degree camshaft that are suited to high power builds only.
Just get it round about top dead centre.
We got the head all bolted up. Robbie's done a magic job on the silicon, hopefully.
Hope so.
We didn't mention it, but it's got 14mm head studs in it. They're custom made from Golby's. So she's tightened up to 130 pound-feet, which is a lot.
There's a bit of tension.
There's a bit of sweating going on over here, doing them up. So now we've dummied up the camshafts. Still waiting for a set of lifters for it, so it's not going to go completely together right now, but can still do the dial-in of the cams.
Yep.
So Robbie's just working on finding true top dead centre, which with the piston stop method, which we have done a video on years ago, but I can't remember what channel it was on.
Yeah.
But we'll go through it again on this one.
Yeah, it's the absolute way to do it, because I've just sat something on the piston to get it pretty close. You can see I've got 0 there. It's, you know, it's not the accurate way to do it, but it just gives us a starting point. But you can put a dial on the piston, but when you've got a good rod ratio, the piston can dwell at top and bottom dead centre for a couple of degrees. So if we do it with a stop, we'll find absolute top dead centre and just be a bit more accurate with what we do. So I'll just back it off, wind the stop down a little, bring it up to the stop. So we're 15.5 degrees the other way.
So we've got to do a full rotation back around.
All right, so and we're around at 8 degrees there, so 15.5, there's 7 there, so we need to go another 3.5 that way, I think.
You're going to try do it again, or do you want me to take the stop out?
That's all right. See, what we need to do is get it the same each side of top dead centre, and then we know that we're on the money. So what are we there? So we're 12. Let's just do that for starters. So 11.5. We're pretty close. I mean, 1/4 degree. So we should be just inside of 12 the other way. That's perfect. Now, a lot of motors I'll have a stopper made. We don't dial in many Barras because they usually got variable cam time, but a stopper is something I'll make in the future. It looks a bit better than a bit of wire. We're going to take that out, Al. Okay, now we've found absolute top dead centre. I've just got a dial on top of the rocker, so we'll find peak lift and we'll go 20 thou either side of peak lift and mark the degree wheel, halve the difference, and that will be the exhaust centre line, which I think from memory was about 113. Yeah, 113 after top dead centre.
So that comes with Kelford cams. That comes with a camshaft, yes?
Yeah, that's a...
Sweet.
Alright, so we're looking on the intake and exhaust centre lines. Once we've got those where we want them, we've got the vernier gears to adjust and we'll be spot on. We'll start lifting. Okay, so we'll go 0. Grab a marker.
Magic.
So what have we got there? We've got 122. So we've got exhaust centre line of 122, we want 118 after top dead centre. So we're we're 4 degrees retarded, so we just need to advance the exhaust cam up a bit. So we'll just go through the same thing again. Back the other way. Back to 20. Pretty much say going by that we've got our 4 degrees, right? Going off the cam carb, we want an exhaust centre line of 118. We've just put it in as it was. You just saw the centre line method. We had 122, so we've advanced the camshaft up 4 degrees. I started by using the increments on the gear, and they were accurate. Two increments meant 4 degrees. As soon as we went back to 20th hour either side on the degree wheel, we could see that it was 4 degrees straight off the bat. And we've got 118.5 degrees, so it's perfect.
Degreeing camshafts is essential to achieve the correct valve opening and closing events to suit the engine. Each engine and camshaft is different, so check your cam card to confirm the correct specifications.
Okay, so we've just dialed in the cam like we just showed you. We were meant to have a exhaust centre line of 118. It started at 122 degrees, so we've adjusted that. The intake was meant to be 113 and we started with 104. So we've rectified that. We've just stuck with Kelford's recommended centre lines for now to start with. Everything's sweet now, ready to go. We can't finish the top end assembly. I'm going to have to pull this apart again and I'll check it again once it's together, but we're waiting on a set of pump uplifters from Golby's. We forgot to order those. They're straight onto it. We should have them on Monday and be able to finish this big girl. I think that pretty much concludes most of the motor itself, Al, as far as what there is to tell.
Yep.
So where do we go from here, Alan? What's the story?
So I reckon once this thing's bolted together, we're going to hear from Millsi pretty quick.
Yeah.
He's already got his Hughes built 4L80 transmission to replace the ZF box that we originally fitted.
Is that the one capable of 10,000 RPM?
It is. We had to have it specially made to handle the RPM of this because they're originally a box out of a commercial vehicle, so they're not a big. We're never made to handle big revs. So Hughes made a billet valve body with short passages, so it would change gears within an appropriate amount of time, so it doesn't end up changing gears at 11 instead of 10. So I think he's actually fitted that up, or his brother's fitted it up.
I think the only thing that's left on the Bedford since it left our workshop was the engine mounts, maybe?
The cross member.
Everything
It's got a
else
new
is-
turbo on it, which is for this engine.
New turbo, new manifold, roll cage.
What is the turbo you're using?
G42 1450 with
Right.
a 127, I think, exhaust housing.
Big dog.
So didn't we just build a 1500 horsepower engine that's with a turbo that's not going to make 1500
Yeah, but you
horsepower?
can always bolt on a bigger one.
It's got scope for improvement.
So
He won't have to do 10,000 revs to use that turbo.
we're done for the moment. Massive thanks to Robby for having us on a Sunday.
pleasure,
Yes,
mate.
it's a Sunday and we're building Barras. So thanks for having us. Thanks for Mrs. Fox for bringing us some refreshments.
Thanks, Deb.
Thanks to Golby's for supplying all these parts. Millsi for spending lots of money and letting us film it.
It's been a fun build.
Yes, it should be interesting. This thing's got 296 degree cams in it, so it actually will sound good, unlike most Barras.
Yeah, she'll be
So-
cranky.
We're looking forward to fitting it up, and you're probably going to see that sometime soon, because once it's put together, I'm sure we're going to see the Bedford turn up at the shop ready to change it all over. So looking forward to that as well. If you want to see more of this man, go and check out our Fox Mustang series where we break stuff and he helps us fix it in America. If you want to go and check out the Bedford, head over to MCM TV 2. It's on that channel on our previous life of the skid factory. That's all we got for the moment. Thanks for watching, and we'll see you next time.
Thanks, Robbie.
No problem, thank you.
Thanks, Rowan.